that today. It's the last main thing we do this week, finishing up before exam 3. So that chapter is available on Blackboard. So some questions from last time. EC is asking more examples of risk-averse preferences we talked about. So as a quick review, so last class, I finished up my discussion of benefit cost analysis, and we added, what do we do with uncertainty? And so you can include uncertainty into benefit cost analysis. We did a very simple example with something we have a lot of uncertainty about, climate change. And so we know we already having damages from climate change, but we don't know if we're going to get lucky and it'll stay small, if we're going to most likely it's moderate, but there's 28% chance large or very large damage scenarios. And so we showed you just do a weighted average. If you can assign a probability to each future scenario, and you can assign some benefits to avoiding those damages, then you can just do a weighted average of that. And so you just do a expected net benefits is you just do a weighted average. You just take this has to add to 1, so you're just taking the probability of each scenario times the net benefits from that scenario. And so if this number is greater than 0, then it's efficient to do the policy. Again, this is saying we got to make a choice today. We do not know which of these scenarios is going to happen. But again, my quote is, uncertainty is not an excuse for inaction. You write down the science the best that is possible, and then make a decision today anyway. Right? Same reason why we buy insurance. So, but this is assuming risk neutral preferences. So this question is about risk averse preferences. So we finished class. Just doing a weighted average and doing expected net benefits is assuming risk neutral preferences. And economics is math applied to people. We take people's preferences as they are, and we want to add rigors of every problem in environmental economics is a constrained optimization problem. So you just use the tools of math and you apply it to this constrained optimization problem that people are trying to solve. So I view it as combining math and people. So but we got to know about people. So it is a social science. People don't have risk neutral preferences. They have risk averse preferences. So that's a problem with our math. Then we would have to factor in risk averse preferences, not risk neutral preferences, and adjust the math here, and instead of just doing a simple weighted average. And so we did this lottery to show that. I'm definitely playing this lottery. I just want to know for sure I'm going to get 500,000 or 300,000. Here is almost certainly you get 500,000, but there's a very small chance you lose 10 million. Like most people are going to not want to play this lottery. This is a very small chance, but that's a very large negative number. Right? So this is an extreme case of showing that what we show is the expected net benefits is the same. If you actually do the weighted average of these two lotteries, you end up on average you're going to get 395,000. Again, this emphasizes you never actually win 395,000. You are either going to win 300,000 or 500,000. Here, you are almost certainly going to win 500,000, but there's a 1% chance you lose 10 million. Right? This is just the weighted average to incorporate uncertainty to see, because we don't know. Obviously, you're making this choice before you know which scenario actually happens. It's just either this happens or this happens. On average, you're going to come out ahead, but obviously, you might just get that one out of 100 people is going to be unlucky. So, okay, so that's the review. And all right, well, the summary is then, what does this mean for many environmental problems? Well, many environmental problems, particularly climate change, does have a high risk, a low probability, but high risk, high damage scenario, just like that lottery B where there was a 1% chance of minus 10 million. And so that means we would want to weight up more these very high damage scenarios, which means then it is efficient to do more today. This is just taking people's preferences as they are and incorporating that in. So that strengthens the case. So not only is uncertainty an excuse for an action, that high damage, low probability, but high damage situation, because we have risk averse preferences, says do even more today so that we can minimize the chances of that happening. So that was our conclusion. Okay, so Macy said, what are some other examples? You've taken other environmental classes, you probably haven't done expected benefit cost analysis. That's a very economic-y thing. But maybe you've heard of the precautionary principle. Maybe you've heard of the precautionary principle. Right? It's a common term. Who's taken other environmental classes other than this one? Majority of you, right? Did you talk about the precautionary principle? Really? This is the environmental ethics or environmental science, or did you talk about the precautionary principle? Huh. Okay, I just assumed that you'd heard of it. Okay. Well, I would say risk averse preferences supports the precautionary principle. And so we can click on this link and dig into what is the precautionary principle. This article states, just shift the burden of proof. In that if you're not certain, it's the same idea of if you have uncertainty, lean towards more caution rather than, well, let's just do it and see what happens. That's the idea. I mean, precautionary principle is have caution first. If there's uncertainty, have more caution. And that would make sense if we have risk averse preferences, which generally citizens do. So that does support the precautionary principle. And so this reminded me of a few years ago, the United States passed laws to update chemical regulation, toxic chemicals. And so I have several articles here. So let's look at that. Do this real quick. So one of these is, I like it, it's just 2 pages. PBS had a summary of this. It was passed in like 2017, 2018, so about 5 years ago. Now, how many of you even know what the rules are on toxic chemicals? Have any of you talked about this in your class? Do you even know? The burden of proof is upon the EPA. There are no rules. It's up to the companies create chemicals, and then it's the burden of proof is on the EPA after the fact to build up evidence to say that maybe is a chemical that has harm to society and therefore is efficient to regulate it. This is so you might think the government has carefully reviewed every chemical for safety before it hits the market. That is absolutely not true. That's not the law. So if you think that, that's the incomplete information market failure, right? You have not been fully informed. Now, pharmaceutical drugs, that is the law. A drug has to go through trials. It has to be proven safe, and the side effects have to be known and just determine that it's worth it, that there is enough benefit of the drug to offset the side effects before it can be legally used. So that's true for pharmaceutical drugs. Chemicals is not at all. Chemicals are, we created it, we throw it out there, EPA, it's your job to figure out if it's safe or not. It's the opposite. There are 80,000 chemicals registered for use today. Practically none of them have been studied for safety. But that was updated. The Toxic Substance Control Act in '76, somewhere in like 2015, that was updated. But it's just so far behind now. There are 60,000 again commercial chemicals without safety testing. And so what the new law says is before regulators had to prove a substance posed an unreasonable risk before they could take action. Right? So the burden of proof was on the EPA. It took them forever. They couldn't even ban asbestos, even though it was killing 15,000 people per year. It was this unreasonable risk they kept getting sued over that, and they had to prove whatever that means for unreasonable risk. So the new law, that was updated, but the new law requires the EPA now to go back through this backlog and test tens of thousands of unregulated chemicals currently on the market. There are 2,000 new chemicals introduced each year. I mean, they've chosen like 10. They're like, well, let's start with the 10 that we think are the most harmful. And they have 7 years to study it. They don't have enough money. They haven't even gotten through 10. Like, this is going to be hundreds of years. It'll be hundreds of years before the EPA ever catches up. Right? At this pace, it could take centuries, hundreds of years for the agency to finish its review. It's 20 at a time, 7-year deadline, and then the industry has 5 years to comply or sue them, which certainly they'll do once the rule is in place. But at least it does. The law says manufacturers have a hard time making trade secret claims for basic chemical information. So at least manufacturers do have to tell you the chemicals that are being used. Right? So that's part of having complete information. So it's just information on where we are. So EPA doesn't have enough money to review even the most dangerous chemicals on the list. Doesn't give them enough money for this large backlog. So it's what I said there. It will take EPA again hundreds of years. So basically, right now the burden of proof is on you as a consumer. There's 80,000 chemicals out there. It is your responsibility to not buy anything that has chemicals in it that are harmful, because it's so. The question is the precautionary principle. So with risk-averse preferences, I would argue it's generally efficient to have a law that forces upfront costs to prove a chemical is safe before we use it. Right? So make this like pharmaceuticals. You want to introduce a new chemical, you prove it safe. Give us the evidence, you can use the new chemical. Right? Why is that burden of proof upon an underfunded EPA, one department, to go through 20, 60,000 chemicals? Instead, just say, if you want to introduce a new chemical, you prove it safe, have it reviewed, just like pharmaceuticals. So that's the cautionary principle, right? That would support risk-averse preferences. So this would be another example that flip that burden of proof. Let's not introduce a chemical and just wait 60 years and just see, oh, we were wrong. Probably shouldn't use that chemical. If we had risk-loving preferences, then it would support that. If we had risk-loving preferences and we were just like, we don't care, introduce a new chemical, we just want to go to the store and buy stuff as cheap as we can, and if there's some risk later, we'll deal with it. The way the law is now is more a society that has risk-loving preferences. If we have risk-averse preferences, and the precautionary principle goes along with that, would say, let's prove a chemical is safe first before it can ever be allowed to be used. That would be an example of that. So I would generally say, and that benefits from this law would be positive if we said, we're going to update the law again and say, it's your job. 2,000 new chemicals every year. You prove it's safe first before you can introduce that new chemical. That's the idea. Jacob. So we talked about risk-averse preferences with greenhouse gases and climate change, and Jacob is wondering, our risk averseness is subject-based. Absolutely it is. By law you have to buy car insurance, but I think most people would anyway, just because you can imagine crashing in a car and realizing your $10,000 car is totaled, or you could be seriously harmed with healthcare costs. You want to have insurance against that. That is immediate to you and something you can imagine. Climate change is completely the opposite of that. But that's not economics, that's psychology, right? So that's why I love the U.S. education system and our broad-based gen ed. Right? Take environmental economics, take a psychology class, take a geography class, take a politics class, take an environmental science class, right? To see a little bit from all the disciplines. Climate change is a major issue because our evolutionary brains, this is like the worst. Right? This was like one paragraph I cut from this article, and I was like, I'm just going to underline what's important, and then I realized I just underlined every single word in the whole paragraph. So you can just read this. But the summary here is basically, our brains work great for an immediate danger that we can envision right now, ourselves or immediate people we love. Climate change is exactly the opposite of that. Huge uncertainties. Somewhere here. Oh yeah, uncertainty creates indecision, right? So we covered that. You just do expected BCA. That's not a reason to not do anything, but most people, our brains will be like, well, I don't know. So again, not making a choice is making a choice. Complexity creates confusion. Okay, well, there's uncertainties with climate change. It's an incredibly complex problem. Distal impacts, that means far away. Yep, it's far away into the future. That means we're going to care about it less right now. And so, yeah, it is very difficult. And so, this article was about cognitive barriers to overcome. How in the research suggests it's possible. But I mean, my opinion on climate change. The science is quite clear. There's just a little bit of uncertainty on how bad the damages are going to be in the future, which we just covered. But what are we going to do? I mean, my opinion is we're going to wait too long. All the cheap options, we'll miss the cheapest option opportunities, and then we will still, when it becomes imminent and more of a clear danger and it rises in salience to the average citizen, we will crank up action and do more. But it'll be more expensive, and we'll have to do more expensive things. Maybe pulling carbon out of the air and doing other more expensive things, just because psychology and politics is too hard, and we're not going to wait, and we'll wait until it seems like an imminent danger, like a car crash, and then we'll do something. So I think the evidence supports that. So it's a tough one. So I am optimistic, tragically optimistic that we'll do something when we have to. Average American doesn't feel like we have to do it yet. Liz is asking. Okay, then last thing I talked about last class. So that's all benefit cost analysis, and then local economic impact analysis. Can that be applied for anything? Absolutely, you can use this toolbox for anything. Take my benefit cost class in the spring and go into this in great detail. Let's say, right. So if a factory closes here in Toledo and opens somewhere else, that's a transfer, right? So you've lost economic activity here and you've gained it here. But it's not just why do we care about such things? Because it's not just the people unemployed from that factory. It is they went and spent money at local stores and restaurants, and so you have a multiplier effect. So the local hit is more than the direct impact. Local economic impact analysis would count that. And that's important. If you're the mayor of Toledo, you would care about that. But in terms of benefit cost analysis, right, if you close the factory here and you open it here, it's just a transfer. You have multiplier effects that bring this region down even more than the factory closing, but you have multiplier effects here that bring this up even more. And it's still a transfer and a wash. So if the federal government is a transfer, it would wash out of BCA. But locally, absolutely these things matter. But again, it still is a transfer. Same thing if you look at bird watching coming to Toledo area in the spring. Today I'm going to talk about how you would capture the benefits of this for a benefit cost analysis. You want to look at the recreation benefits to bird watchers versus the real resource cost to pay people to staff the parks. Of course, if people come here, then they also get a hotel, buy food, fill their car up with gas. So that's also bringing money locally. And then local impact analysis, but you do not include this in a national BCA. Again, if they didn't come here, they just go somewhere else and buy food and buy gas and sleep somewhere. So that's just a transfer. But you do want to include the actual real benefits. Okay. So last major topic we're going to cover this semester. This supplemental chapter I just handed out called Aesthetic Values of Lakes and Rivers. Me and two co-authors wrote this for Encyclopedia of Inland Waters. It was for limnologists, and so they wanted to include some non-market valuation at one chapter in there. So basically, I think this is a good chapter for this class. It is explaining to environmental scientists, water experts, non-market valuation for benefit cost analysis with no economic background, right? So it's like this is an environmental econ class with no prereqs. So I'm trying to explain it to knowledgeable people, but with no econ background. So non-market valuation, what is that? That's placing a dollar value on environmental public goods that are not sold in the market. That's why it's called non-market, right? So it's easy to find people's value for a new car or a new computer or clothes or chocolate almonds at the store. Did you go to the store and buy it? Well, it's worth more to you than the price you paid. You can just see how many people are going to the store and buying it. But non-market valuation, if we want to treat environmental public goods the same as things you go to the store and buy, then we also got to estimate the worth of these things: clean air, clean water, parks, trails, wetlands restoration, increasing wildlife habitat. Right? These are all environmental public goods. So this is my area of specialty, is doing this. So non-market valuation can be broken down into three types of values. The first is use value. Just as it sounds, it's willingness to pay for direct use of environmental good. Right? So if you go out to Maumee Bay State Park, we actually solve the algal bloom problem and E. coli problem, and it's clean water, and you go out and swim there. That's use value. Right? You're swimming in a clean lake. You're directly using that clean water. Option value. The second one is option value. That's willingness to pay for future ability to use the environmental good. It's still use value, but now it's future use value. Right? This would be, well, I want this lake cleaned up because my kids are little now, but I'm going to take them in the future. I want to have a clean lake nearby to take them. Right? So it would be option to swim with future children in clean lake in the future. So it's just future use value. And then non-use value is everything that's not the first two. It's just catch-all term. So it's willingness to pay for an environmental good, even though you have never, so it's not use value, and you will never, it's also not option value, visit the environmental public good. So I'm not going to go now. I'm never going to go in the future, but I still want to take dollars out of my pocket and support this environmental public good. That's non-use value. It may more commonly be called just existence value. I have willingness to pay that I just care that this exists, even though I'm not going to directly use it myself now or in the future. Right? So this would be willingness to pay for a clean lake, even though you don't visit now or ever, but you still have worth for it. So that's possible. In many environmental public goods, non-use value could be the largest category. I mean, this would generally be far. When would that be? When would this non-use value be the majority of willingness to pay? It'd have to be a far-off environmental public good, right? Arctic National Wildlife Refuge, constantly debating if we develop that for drilling for oil or natural gas. It's very remote in the Arctic. It's in Alaska. Practically nobody goes there. There's no roads, and so that's that trade-off of a very remote, pristine place. Do we develop it a little bit for humans, or do we leave it in a very remote, pristine state, without human activity? Well, that's how you're going to estimate the benefits of not developing it. Is almost entirely going to be non-use value. Practically nobody goes there. But I could still do a survey to all Americans to find out their non-use value. How much benefit do you have to leave it in a preserved, pristine state, even though you have never and are never going to go visit? So non-use value is very important. For many far-off environmental public goods that don't get visited a lot, it's primarily non-use value. And these are all separate, so you just add them all up. So your aggregate total willingness to pay we talked about previously. Again, all benefits comes from people's willingness to pay, right? I'm just directly surveying what your preferences are. So I just add up use value, people's value from using it now, people's value from using it in the future, people's value from non-use, that they're not using it now or in the future. These are all mutually exclusive, so you add them up. So you add it up across all people, and that's the total, and that's the benefits. So if it was the Arctic National Wildlife Refuge, it would almost entirely be non-use value. But there's a few people who visit or who want to visit in the future, so then you just add it all up. Like I've written down here, but I didn't show it very well. Again, Wildwood. The most visited metro park in Toledo is Wildwood. It's very centrally located, right on Central Avenue there. 8 miles of trails, nice place to run, walk your dog. So this is almost completely use value. Right? This is local use value. But we have another metro park that's not visited very much because it's further away, mostly because it's further away. So if I was doing Wildwood Metro Park, I would just go directly and survey people who come to visit it, and it'd be like, it's okay, I've gotten 95% of the benefits. If I was looking at Oak Openings Metro Park, it would be more of a problem to only get use value and survey people who are using it. The primary thing about Oak Openings, my understanding, it's preserving a very rare oak savanna habitat that is unique in the nation. Well, if they're unique in the nation, then that means I would need to survey the nation and find all of the more environmental people who know about this and care about preserving oak savanna habitat. So that would be more non-use value. So that would be less just people directly visiting Oak Openings, and it would be more about preserving a rare habitat that is unique to the whole nation. Right? So then this part's going to go up as a majority of the total. So it's more of a problem if you're leaving it out. Right? If it's the majority, then it'd be an issue to leave it out. I have no problem saying I'm estimating the benefits from Wildwood, and I just go and estimate the people who use it every year. No problem. That's the majority of it. So it'd be more of a problem if you're looking at Oak Openings. Okay, so we now have taken our willingness to pay and divided it into 3 buckets: use value, option value, non-use value. Well, how do we actually estimate it? Well, there are only 3 ways, and I've done all 3 that environmental economists have to estimate these environmental public goods. The first is the travel cost method, or it's also known as the recreation demand model. Now, this is only like that first category. This is just use value for visitors. So it's a recreation demand model. It is, I observe that you came to Wildwood and you took some trips. And so I can observe the time and effort you took to get there and how many trips you took to get there. That's a recreation demand model. I'm estimating your demand for recreation at Wildwood. So it's only use value for visitors. And so what we're doing is we're estimating the consumer surplus, right? Concept I introduced back in chapter 3 at the beginning of the semester, right? From the recreation trips. So it's only use value, but again, in many instances, that's fine. Second is the contingent valuation method. It's also known as an advisory referendum. I've changed to calling it an advisory referendum because it sounds more meaningful about what you're actually doing. It is the most powerful method because you are directly estimating aggregate total willingness to pay. You are getting use value, option value, and non-use value. It's very flexible. You can directly estimate total willingness to pay. It's the only method. It is the only way you can get non-use value because you have to do with a contingent valuation method or do some type of an advisory referendum because you're just directly asking people for the willingness to pay to get an estimate of it. So it's not based on, you can tell me that you put dollars towards this even if you never go now or in the future. So you are directly, it's the only way you can get non-use value. So it is quite common method. The last one is hedonic property value analysis. Again, this is only use value, and it's only to homeowners near an environmental public good. So I'll quickly review these three methods. So this is it. This is the entire list of ways to value and find the benefits for benefit cost analysis for environmental public goods. So this is just if you have a house, like last paper I did was looking at homes in Ottawa Hills on the Meadow, just looking to see, get one house on the Meadow that looks out over the Meadow versus a similar house that just looks at, is in a typical neighborhood that just has houses surrounding it. This house sells for $10,000 more. That's the willingness to pay for the Meadow. Right? You're willing to pay more for a house that is right near this environmental public good than a house that isn't, once you control for everything else. So that's a hedonic property value analysis. Okay, so today I'll start with the travel cost method. We'll just go through each of these, and that's what the chapter I handed out talks about, each of these methods. So the travel cost method, or recreation demand model, same idea, is right. We want quantity and dollars trade-off, and that's what the travel cost method gets us. Q here is the quantity of recreation trips, and the price of that recreation trip. You could visit Wildwood for free. You can visit Opings for free. You can visit all the parks in Ohio for free. But unless you have, until we have time travel, you can't just snap your fingers and immediately show up there. So there still is a price. You got to get in your car and drive there, or somehow get yourself there. So that's money out of your pocket, and it takes time. So we're going to I monetize the cost out of your pocket and the time cost for you to get there. So that's the price. That's the travel cost. So if there was a price to get in, you would just add that in. Then it would just be travel cost plus entry fee. So whatever your total price is to take these trips. And we generally are going to expect a law of demand. Right? As the price, your travel cost goes up, it's going to lead to you taking less trips. But as it becomes cheaper, this is going to lead to you taking more trips. That's why we have this demand line. So imagine two people. So assume you are person I. So you're down here, you're person I. You have lower travel costs. So that means you live right near Wildwood. Right? You live right near the park. And so on average, all else constant, right, I would expect to observe you taking more trips. Right? You would have a higher number of trips. Right? You can just go over there to walk your dog every day. Right? So we would expect you're going to take higher QI's quantity of trips since you live near the good. And then so we want to look at is what is your total consumer surplus going to be versus person J, a different person, further away from Wildwood, is going to have a higher travel cost. And Wildwood is still the nearest metro park to them, but they live further away from it. Then we would expect that they're going to take less trips. Right? Again, on average, all else constant. If it's cheaper for you to go there, you go more. If it's more expensive for you to go there, you go there less. So that's what we're showing here. So it's just using a law of demand. And so now to get benefits out of this, we want to look at consumer surplus. Recycle that concept. All right, so a reminder of what consumer surplus is. So consumer surplus is willingness to pay minus price. Or I think of willingness to pay as worth. Consumer surplus is value. This is how I talked about it way at the beginning of the semester back in chapter 3. All right, so value equals worth minus price. So willingness to pay is, again, the willingness to pay. It's your willingness and ability to pay. It's the maximum dollars you have to put towards this recreation trip. But you got to subtract out the actual dollars you have to spend, right? The price of the trip, the travel cost. And then what's left is value. That's consumer surplus. That's dollars you would have put towards the trip, but you didn't have to. It's the leftover dollars in your pocket that you would have spent, but you didn't have to. That's value. And so for person I is going to get more value because your cost is low. And so your travel cost is low and you go a lot. Then consumer surplus, and again, demand maps out your willingness to pay. So it's willingness to pay minus price. So you get lots of consumer surplus in the first trip, but that consumer surplus diminishes. Then you get less consumer surplus, but a positive amount on the second trip, third trip, fourth trip, fifth trip, sixth trip, seventh trip, eighth trip, ninth trip. Well, so if I can estimate out your worth function, and again, this is still abiding by the law of diminishing marginal willingness to pay that we did back in chapter 3. That's a law. This is always true. Even if you're walking your dog at Wildwood every day, like your way over here, do you want to go there twice a day? No, I already went once. Right? There's always diminishing willingness to pay. And so that's what that's mapping out. And then so you just compare that to your travel costs, and this is another opportunity for me to emphasize the equi-marginal principle. Right? Every decision you make, if you're doing a constrained optimization problem and you are rationally making the choice that optimizes the value to you, is you're doing the equi-marginal principle. How many trips are you going to take? Keep going, keep going, keep going, keep going, keep going, stop. Now, all of this area is consumer surplus. This is consumer surplus per trip. And so total consumer surplus is all of the area of this triangle. You have maximized the consumer surplus to yourself by taking 10 trips. You don't take an 11th trip because you've already gone 10 times. And maybe this is per week, I don't know, a month. And you think, well, do I want to go again? And you think, nah, I'd rather do something else. The worth has now fallen below the getting in the car, driving there, and the time it takes up. So that's the equi-marginal principle. Your to maximize your total consumer surplus, you're going to take the quantity of trips, Q star, where you keep going until the marginal willingness to pay equals your total cost per trip, which is really your marginal cost per trip. They call it total cost. Therefore, you've gotten all the trips where you got some consumer surplus. So in total, then, the consumer surplus here is always the area below demand and above price. Is true of consumer surplus for every good in the economy. My son Kate loves Little Caesars pizza, which makes me incredibly happy as a dad because it's super cheap, right? And so he likes it a lot. So there's a lot of consumer surplus there. So I can estimate consumer surplus of anything. And so you can do the same thing for environmental public goods. As long as I can estimate the demand, I just need to estimate this demand curve in your travel cost, and I can estimate your consumer surplus. And so here, I labeled these endpoints. So this is triangle A, B, C, ABC. Total consumer surplus is this area ABC. That's summing up all of the marginal consumer surplus you're getting from the 10 trips. So travel cost model is just doing, it's what's called recreation demand. This is the recreation demand curve. It's just using the law of demand. Now, if you're the person who lives further away, then you are not going to have as much consumer surplus. You don't get as good of a deal because your price is higher, right? Person I was down here, right? So they had more consumer surplus. As you increase the price, then we assume rationally, right, from here, as you increase the price, you take less trips, and those trips become more expensive, right? So this triangle shrinks. The equimarginal principle to you is you're going to take less trips, and those trips cost you more. So you still get some value, but the maximum value you can get is less because your travel cost is higher. And so then, so again, once I can estimate this demand curve and I know everybody's travel cost, some people are going to have a high consumer surplus, some people are going to have lower. And so this would be someone with smaller total consumer surplus to them. And again, this is the relevant benefit to include in the benefit cost analysis. If the park, let's say Wildwood, the Toledo residents in the 60s or 70s, right? They passed a levy upon themselves to buy all of that land and keep it from development because it was going to be developed. It was, I mean, if you go to the manor house, that was the original house, and all that land around it was private land, and it was going to be developed, right? And some environmentalists at the time rallied local citizens and got it on a ballot and said, let's collect some tax dollars and buy this and preserve it as a park and not let it just become some more housing developments. And so that was successful, right? So now it's a very valuable, that park is, I can prove it as an environmental economist, that park is way more valuable as a park than just sell it off for zoning for houses. But where does the value come from? It's the consumer surplus. If we took that park and we just, let's say the city of Toledo, the Toledo Metro Parks gets a renewed levy every 10 years. Let's say citizens' preferences change, the levy fails, and someone puts a ballot initiative that says, housing's expensive. Let's just, how many houses we could put up in Wildwood, right? It'd be thousands. We could fit thousands of houses in there. Let's just zone it and build a bunch of houses. I could estimate that. I could look and see what the value would be to make it as houses, but what's the opportunity cost? What is lost? It would be the consumer surplus to every person who was going there to visit it. That's what's lost. Right? So that is lost value. That is the true value of that. Now notice, right? You subtract out the travel costs, right? So consumer surplus is the money in your pocket. You would have spent on something, but you didn't have to. That's the value. If you take that thing away, you lose the value. The money you actually took out of your pocket and spent on that, if that thing is gone, you just take that money and spend it somewhere else. Right? So this is important. In benefit cost analysis, you include the money left over that you didn't spend. In local economic impact analysis, you include the dollars you did spend. It's completely different. Oh, you took dollars out of your pocket to get there and buy some gas and some food. That's travel cost. That's why benefit cost analysis is different from economic impact analysis. The true value of something is the consumer surplus. This is the correct way of doing it to prove that preserve Wildwood as a metro park. Don't turn it into houses, because if you add this up across all the people, it is massive. It's not even close. My guess would be 1,000 to 1. So if we have only 2 people, then you just add up the consumer surplus for both persons. Why can I just add consumer surplus to person I and person J together? Because it's the public good. It's not rival. They both can go and enjoy the park at the exact same time. So if there are 300 people that visit a day, then I just estimate the consumer surplus to each one of those people, and I just add it up across 300 people. That's why your consumer surplus to go walk your dog there may be $3. Well, take $3 times 300 every single day all year, and it becomes a very big number, right? Because public goods are special. They are not rival. If I have consumer surplus of $3 to grab a pizza from Little Caesars and take it home and eat it, that's it. That's the whole consumer surplus for the pizza. It's rivalrous. If I eat it, nobody else can eat it. But we can all visit the park at the same time. So you just add it up. So small numbers can become very big numbers. So let's say you live near 2 lakes. Lake 1 has lower water quality, and Lake 2 has higher water quality. You can see that our recreation demand analysis here, if you live near each of these lakes, the one with higher water quality, I'm going to estimate you get more consumer surplus. You're getting more value to be living near a high quality lake than a low quality lake, because this demand curve is going to be further out. And what causes that demand curve to be further out that I estimate comes from observing how far people are willing to travel to get there. So if you live near a lake that is of low water quality, okay, maybe you're going there just because it's convenient and it's nearby. But people are people are not going to travel that far to come visit it. Right? That's what I'm saying here. The maximum travel cost that we observe anyone paying is low. And so that brings the demand down. And so I estimate you have a low consumer surplus. If you are lucky to live right near a park that has very high water quality, there's two things that shift this demand curve out. Number one is you're going to go more, right? If you live equidistant, you can go this way 5 miles to a low water quality lake, or this way 5 miles to a similar site but higher water quality. Most of the time you're going to go here. I mean, people like variety, so maybe 10 times you go here, 1 time you go that way, just to mix it up. So variety is preferences that people have, but most of the time we're going to observe you going here. But it's not just that you go more; it's that here it's just you and only like your local neighbors who are within 5 miles. But here, if you're going a lot, and we observe somebody driving up from Columbus to go there, or somebody driving 100 miles, they may only go once. Right? They may only go once, but they came from a long ways. That indicates that there are citizens willing to take much bigger dollars out of their pocket just to come here one time. And so I estimate that shifts the demand curve out, and I say, wow, lucky you. You are really lucky. You go more, but also we are observing a few other people drive from really far away to visit this place, so you have a lot of consumer surplus. This is a valuable lake. Right? So that's how we can estimate that. So person I here is getting lower value consumer surplus from a lower quality lake and higher consumer surplus from the higher quality lake. And again, it's just observing. You go more, but also we observe other people. Maybe they only go once or twice, but they're coming from really far away. So we would observe that. All right, so next, if you understood all that, we'll do an in-class exercise. We can put this all together. So your in-class exercise for today, this is figure 4 in the chapter I handed out. Okay, so how can we directly estimate the willingness to pay, the worth, for a water quality improvement at a lake? So think about this. We have these 2 lakes. 10 miles this way to this lower quality lake 1, 10 miles this way to this higher quality. What if we could clean up the water over here and make it have the water quality equal to this lake? What's the worth of that? How can I do a simple, just only using recreation demand analysis, how can I estimate the worth of that? That's what your in-class exercise is. So how can we directly estimate the willingness to pay for a water quality improvement at the lake? For example, imagine we increase the water quality at lake 1 in that previous piece of paper equal to the water quality at lake 2. So just think about it and write down an answer, and then we'll go over it. Right, so just imagine, right, we're taking lake 1, making it look like lake 2. How would we estimate the willingness to pay, which is benefits of that? So what do you think?
We sort of take the total value of lake 2 and subtract value of lake 1 and the difference out of your methods.
Yep, it's just the difference. It's the additional consumer surplus from the additional trips. Additional, right? You got to take this minus that. Yep, that's exactly it. So this is figure 4. Right there, I just explained figure 4. It's the benefit is area A, B, C, D. It's the additional consumer surplus from the additional trips. There were trips before. We improved the water quality. What is the extra consumer surplus from the extra trips? Right. So 2 states of the world. We already had some consumer surplus before, but how much extra additional consumer surplus do we get because we improved it? And that's an actual picture. So I did this research back at Iowa State. You're going to go visit that lake? Oh, that's awful, right? So no one's going when the lake looks like that. That's, that's a eutrophic algae, right? That's a very strong algae bloom. No one's getting in the water, right? So if it looks like that, no one's going. But this is Clear Lake. It's called Clear Lake. It used to be clear. If you could actually make it clear again, people are going to start going there. That demand curve shifts out. Maybe you might still go there and fish, but you're not going to swim in it. You're not going to boat on it. So the recreation demand is going to shift out a lot. If you can actually, this used to be a Clear Lake. I go back and clean that up. So I can directly estimate the benefit of that. It's just how much does the demand curve shift out? How much extra consumer surplus do we get to everybody added up? That's it. So that's what this shows here. So you just look at, when it's a low quality lake, maybe some people go fishing a little bit just because it's nearby. So you get this area BEC, right? This is the consumer surplus you had before. So now you did some policy to clean the lake. I would just estimate the extra demand that would come from that. If you live, again, two reasons. You live nearby. Well, you're going to go more now that it's been cleaned up. And if the lake looks like that, maybe you go because it's right next to your house and just fish a little bit. But nobody else is coming to this lake. But if this was actually, Clear Lake is actually the second most visited lake in Iowa. Not when it looks like this, but at times of the year when there's not an algal bloom and it is clearer. But improving it so it never looks like that, you're going to get more trips. You go more because you live nearby, and people from further away go more, right? You get these people who, I'm not coming now, but okay, now I will go once or twice as a place to vacation. And so the whole demand curve shifts out. And so all of the consumer surplus now is A, this is A, this is E, this is D. So I'm just using endpoints to identify area. So you take AED minus DBC, then you end up with ABCD. Area ABCD. Right, so it's just the new consumer surplus minus the old. So your benefits end up being additional consumer surplus from additional trips. So I would estimate that this is the benefits in a BCA. Benefits for BCA. Right. Everything's monetized. And then I would just compare it to how much is it? What is the real resource cost to actually make that happen, to clean up that lake? Around Clear Lake, it's been done. We did the research. It was one of the 8. If you're only going to pick 8 lakes in the states to clean, this was one of them. It's egg runoff from the surrounding watershed. It is a natural lake. It's not part of a river system, so it is any lake that's a part of a river system. Just forget it. You got to clean the whole watershed river system. But if it's a natural lake separate from a river system, you can just work around the watershed and the land around it. It would take a lot of riparian zones, buffer strips, more careful fertilizer application around it. But it's not even close. I could estimate the benefits from this, again, 100 to 1. So it's 100 to 1. That Clear Lake does not look like that based on efficiency. But Clear Lake looks like this every year. Government failure, right? So the government is failing to manage the land around Clear Lake, and society is being harmed because it is not getting the maximum net benefits from this lake that it could get because Iowa is failing to properly manage with efficient rules of the land around it. And so same thing with now just Lake Erie, same thing. Lake Erie, I haven't seen it that bad. So sometimes it's that bad. And so that's a government failure to manage the watershed from the Maumee River. So we're stuck with this much value when we could be having this much value. But it's the new value, right? You take the new value minus the old value to get the additional value, which is consumer surplus. There used to be 38,000 visitors a year out to Maumee Bay State Park. It's nowhere near that now, right? Before the algal bloom problem, we were here, and now we're back. Now we're down here. So I could estimate in reverse. I could be the lake got worse water quality. How much value did we lose? I could estimate that. That would be the benefits lost because we haven't done anything about it. So add it up, it's not close. 100 to 1. It's 100 to 1 to clean Lake Erie. We're just not doing it. Economics is easy. You can pay me one study and I can do this. I've done it several times. In my lifetime, if we solve it, I'll be happy. So that's what I've written down here. So now you compare this benefits to the cost to actually clean up the lake, right? So in benefit cost analysis, if the benefits is greater than the cost, net benefits are greater than zero, it's efficient to use tax dollars to improve the water quality at this environmental public good, right? So this method can be used for any quality improvement at any environmental public good. But again, it's most appropriate use value, right? So if we're doing this for Lake Erie, again, this would only be benefits from recreators every year coming out to Lake Erie. It's only use value. But again, the use value would be pretty large. And what I would argue as an environmental economist, I went to a national conference and said this, and I got a line of people lined up to have a conversation with me about it. But what I said was, if I can simply do recreation demand analysis and I can prove it's efficient, the benefits are already greater than the cost, then I'm done, right? Just go on to the next thing. Yeah, I missed some non-use value and I missed some option value. But if the use value is already 100 to 1, I can just say, and it's actually greater than that because I only estimated one piece of the benefit. And so people lined up to be like, you can't just not estimate non-use value. That's really important. And I just spent an hour. Like, yes, it's important. That wasn't my point. So my point as an economist is let's be efficient. My time is valuable, right? Let's be efficient with the research. And if I can prove it's efficient, then just move on and let's go to the next thing and see if it's efficient, even if I've left some things out. Of course, many environmentalists want to know that non-use value is included and existence value is included. And I can tell you I mostly exclude it because I don't need it. I can get the answer just by looking at use value. And it's easier and I can just move on to the next thing. My point is we're not doing it anyway. So we're not even doing this. So why do I need to go do non-use value when I can already tell you this is efficient and we're not doing it? So I don't know, let's be more of a pragmatist. But it is important to know I am leaving out non-use value, which upsets some people. All right, so that's done with the theory of the travel cost method. So how do we actually do it? We've done a lot of theory, since this is actually my research. How is this actually done in practice? Well, I just have to estimate travel cost. So I got to estimate that recreation demand curve. And so the travel cost, one is vehicle cost, right? And so, gas car and a little bit of depreciation as you drive it. That's part of it. But this gives me another opportunity. Again, I just want you to remember 4 things. Every decision you make has benefits and costs. Cost is always opportunity cost. And if you're optimizing, you're doing the equimarginal principle. So again, I got an opportunity to do the equimarginal principle again and to talk about opportunity cost again. But we don't just include the money you take out of your pocket, because you have to take time. You only spend 2 things, money and time. We don't only look at money, you also have to factor in time. And so we must monetize. If you're going to accurately estimate a cost to you, you also have to estimate opportunity cost of time. It is hard, but that doesn't mean you don't do it. You just there's a whole entire literature in economics on how to properly value opportunity cost of time. And generally, a simple thing to think about is, well, I could go work at my part-time job for $15 an hour, or I could go fishing today. And so that's an easy way is to think about, well, what if you could work? What kind of income are you giving up that you then chose to go recreate instead? And so that's a way of looking at foregone earnings as your next best alternative, as a way to estimate opportunity cost of time. So all I need to know from a person is how far did you travel, so I can estimate vehicle cost. Give me an estimate of your income, and I'm just going to estimate a wage rate for you and say, well, you lost some money because you traveled there. And so that is saying the richer you are, your opportunity cost of time is higher. That's absolutely a fact. If you earn more money, and that the opportunity cost of time is higher. So generally how it's done, this is what I use. It's the most typical. If I publish a paper with these numbers, I don't get any pushback, right? It's just kind of what the consensus is in the literature. About 25 cents per mile is, I just estimate how far you went. I just take your round trip miles times 25 cents per mile. Now the IRS will reimburse you like 54 cents a mile, but generally in the recreation demand literature, you only use about half that. Because you're going to own a car anyway, and we only want to really consider the marginal cost, the additional cost to you to take this trip, which is mostly gas costs and a tiny bit of depreciation. But you have the car anyway for work, and in our car-centered society, almost everybody has a car. So you don't do the full rate, you do about half of that. And then I estimate what your average wage rate is, the time it's going to take you to get there back, but then you also only multiply by about a third. Because again, whatever your wage rate is, it's $15 an hour, you don't get $15. You got to pay taxes on that. And plus to kind of compensate, most people don't really have flexibility to be, my son last summer he was a DoorDash driver, which actually is very flexible. He really had to make the choice: hang out with my friends, go earn some money, right? And every hour he could be doing this trade-off: earn some more money, don't earn money, hang out with my friends. But most people don't have that kind of flexibility. It's just you just have a set shift, and so economists have done lots of studies. So about a third. I estimate what your average wage rate is to factor in taxes and not complete flexibility to do a third. That's how I estimate your travel cost. And so now I have an estimate of everybody's travel cost, and now I just ask them, how many times did you go to Wildwood? How many times did you go out to Maumee Bay State Park? How many times did you go to Oak Openings? Now I have a point estimate of your travel cost and how many times you went. Now, these points aren't exactly on a line, right? Because travel cost is just one thing, right? People have all different preferences. Again, this is on average, all else constant. Some people maybe don't go. Maybe I'm sure there are people who live right next to Wildwood Metro Park and they never go, right? They just don't. That's just not how they want to use their time. But then there are some people who live far away who go a lot. But in general, so I just get all these data points, and then regression analysis is you just try to fit a demand line that minimizes wherever I put this line, it minimizes the distance from where the line is to all of these points. So there is going to be variation, but in general, these points are going to head down this way. Right? You are going to see, on average, all else constant, people with lower travel costs are going to go more, and people with higher travel costs are going to go less. So that's what regression analysis is. If you want to learn about that, take Econ 2810, Econometrics. It's Introduction to Regression Analysis. But it's very simply, you just fit a line. You're just trying to fit a line that minimizes the error between where the points actually are and where the line is. And then once I have the line, and now I know what your travel costs and trips are, then I can estimate consumer surplus for every single person. That's what I do. And generally, this is just you can estimate a linear demand. And so we're thinking back to your algebra, right? The formula for a line, right? Y equals mx plus b. People still learn it that way. Y, b is the intercept, and m is the slope. So usually Q is the trips, recreation trips, and so we have the intercept and we have the travel cost as an explanatory variable, and then there's an error term that if your point isn't exactly on the line, that shows and the regression analysis is trying to minimize the error, the difference between where your actual combination of trips and travel costs are to the line. And generally, like this is going to have, the key here is this is going to have a negative slope, which shows as travel costs go up, right? As travel costs go up, trips go down. Now it is Alfred Marshall's fault if we, you want to look at the strength of inertia, is if I was graphing this, every demand graph I've shown you all semester is backwards. It really should be, wait, I'm showing this the right way. In math, you always put the explanatory variable over here, and you would put the trips over here, because this is the explanatory variable. You change travel cost first, and that explains the variation in trips. Right? Trips is the dependent variable. It still has a negative slope, but you're swapping what's on the. And so if you did it this way, then when travel cost is 0, then I could use alpha stars over here. Right, so when travel cost is 0, what's the y-intercept mean? If you just live right across the street from Wildwood, you just walk over. That's how many trips you take when your travel cost is 0. And then as travel cost goes up, now trips start going down from there. And so this is the demand, and so beta hat is the slope of this line. Right? And it's negative because it's negative. So all demand curves should actually have the price over here and quantity over here. Because when I actually do my regression analysis, if I was going to directly graph this line, Q goes here and travel cost goes there. But when Alfred Marshall first talked about demand curves, he flipped it for some dumb reason, and no one's changed it in 200 years. So it's actually, this is flipped this way. And so we always graph quantity here and travel cost here. So you got to flip it. So you flip this to here. But you get it's the same idea. It's like, why are we still using miles and inches and Fahrenheit? And the metric system makes way more sense, and the whole rest of the world does it. But inertia is pretty strong, and it's hard to get everybody to agree to just change once it's already set in place. So the entire economics profession has not changed, and we still draw demand curves backwards. Even though it would make more sense to put price here and quantity here. In any mathematical analysis, you always put the explanatory variable here, and it explains the y variable if you switch it. But this is not hard. I only need 2 coefficients. All I got to do is estimate where the line starts and what's the slope. Now I got the demand curve. So the empirical application is not hard. It's actually like very simple regression analysis. All right, that's it. So that's the travel cost method. So I'll just introduce, and then our last class, I will talk about the contingent valuation method and the hedonic value method. So the contingent valuation method is you directly ask for people's willingness to pay using a hypothetical scenario. I've used the word using a hypothetical advisory. I mostly call it an advisory referendum now instead of hypothetical. It just sounds better. Right? Words matter. People listen to me more if I say an advisory. I'm just advising. It's an advisory referendum. Hypothetical. That's made up. Well, it is made up, but it's a made up advisory referendum. Sounds better. So all I'm doing here is I'm creating an advisory hypothetical referendum that looks like a real referendum. I just ask you, would you vote yes on a referendum, like if it was that water quality at Clear Lake or Lake Erie? It's going to cost you an extra $100 a year in taxes in some way. I have to make it credible on how you're going to end up paying these taxes. But it's going to cost you an extra $100. For Lake Erie, it has to be the state. The state's going to do this. You're going to pay an extra $100 in taxes and income taxes to the state, and it's going to improve the water quality in Lake Erie. Would you vote for it? Yes or no? And then generally, right, when would you say yes? You would say, yeah, I'd vote for that. Well, it would be the case. It would be just like going to the store and buying something. Yes, I would vote for it as long as my worth was greater than the cost I gave to you. And you would vote no if your worth was less than that. I mean, just like we all vote, what did we just vote on in November? Libraries. I don't think Metro Parks. Metro Parks was last time. And this time was library. Library passed. Last time it was Metro Parks. Right, so Metro Parks, about 60 to 70% vote yes. That's people saying they think it's worth it for the tax dollars. 30% of people vote no. They say it's not worth it to them versus the tax dollars. And the key is I just change X. I just vary how much the tax dollars is going to be to you up and down, so I can map out how much people have worked for. All right, my phone dings, so I'm out of time. So do your daily writing, ask a question, write a summary, something interesting per usual, and I will finish up this supplementary chapter on our last day on Wednesday.